All right, question 17. We have the displacement versus time. So here, I'm probably going to want to work with the slope to get the speed. So right away, whenever I see a graph like this, if it's displacement versus time, I just want to right away sketch out the velocity versus time, even though I haven't done any work on it yet. So here, I'm going to have a flat positive slope and then a zero slope here. And then I might drop a line down just to keep the graph continuous. So what do I have? What do you know? Choice B is exactly what we're looking for. Now for 18, a body starting from rest moves along a straight line under the action of a constant force. I'm actually going to write a force F there. After traveling a distance d, the speed of the body is v. I'm just going to tell you right now, I just have this feeling. It says the speed of the body when it has traveled a distance d2 from its initial position is. Whenever I see F and distance together and we have a v at the end, I just want to do the work energy theorem. So let's just first do it for the whole system. FD equals 1 half mv squared minus 0. And I'm just going to go ahead and isolate v here if I travel the whole distance. So that's 2 fd over m under a square root. And that gives me v. Now we're only traveling half the distance. So this is f times d over 2 equals 1 half mv halfway squared minus 0. So I'm going to end up getting f times d over m under a square root equals v at the halfway point. So if we actually connect these two, I want to know how these two compare. Well, v 1 half divided by v equals f d square root over m divided by 2 f times d over m under a square root. And so that's going to give me f v 1 half equals, there's a lot of cancellation here, 1 over square root of 2. So v 1 half equals v over the square root of 2, which is choice C. All right, number 19. We get this cart moving this way. We shoot a cannonball up. Which one of the statements is true? It actually turns out because we have the cannonball moving to the right along with the cart, it's going to actually have this nice parabolic path, and it will land inside the cannon. Finally, the last question. Here we are. Another elevator question. So here we go. Now what do we have acting? We're going to have, here's Mandy. Let's do the free body diagram. We have the scale reading and the weight reading. Okay, so we are accelerating vertically upwards. That means the scale reading has to be bigger than the gravity reading. And the effect is we have the scale reading minus the gravity, and the effect of that is that we get an MA. So we have the reaction force from the scale, the weight reading from the gravity, W. So what do we actually read on the scale? What we read on the scale is the scale reading, R. And that is it for the multiple choice section of the exam. By the way, just to kind of clarify this, what we're saying is that R minus the weight equals her acceleration. So this is what the scale reads, and it's going to read heavier. And the difference between these two can actually be used to calculate her acceleration as she moves upwards. So that's question 20, and we have finished the multiple choice section of the exam.